Introduction to Computers, BCA-101. So the first thing we did, this was on Friday the 22nd, we reviewed the concept of having this huge amount of data and moving that data through different levels of information systems, different levels of information, and levels of management, which we talked about before. The data becomes information, allows people at different levels of information to make decisions. And we talked about structured decisions, semi-structured, non-structured. Here we talked about database management systems. All those. We use the example of relational database. Alright, so we've already talked about this example of items outside of the standard deviation and the information system making some decision on that, maybe stop the line or whatever. Life cycle of a system, we're going to go through that right now. We'll talk a little bit about that. Alright, so here we talk about top-down design. We have these different stages, and some people would define them a little bit differently, but they're basically the same thing. We're going to define our issue, our challenge, opportunity. Some people might call it a problem. We're going to investigate that. You cannot solve a problem unless you understand the problem or the challenge or what opportunities exist. We might look for an opportunity that an information system might make our product easier to use, maybe more reliable, maybe a new treatment for something, a certain drug, whatever it might be. We have the whole investigation stage. You cannot start analyzing until you know exactly what you're investigating. Then we have the analysis stage. In there we will do a cost-benefit analysis of whether this makes sense. Then we get lots of feedback. We analyze some things, bring them back, have people look at them, reanalyze them, and so forth. A great example would be you have a family and you live in an apartment and there's not enough room, so you have a challenge. So your problem is you don't have enough room for your family. So then you could do all this analysis. Could we build a house? Do we buy one that's built? Do we keep renting? And in that analysis you're going to look at how many bedrooms, do you want an attached garage? How important is the garage? A basement? The efficiency of the house, location of where you want to live, etc., etc., etc. Lots of things to be analyzed. You do a cost benefit, and how much it's going to cost, or what is your budget. Anyway, once you get to, let's say you plan to build, then you'll design it. Lots of feedback with the different people involved. This would be like in a house scenario, blueprints and those things. Information system, you would analyze all the different places that information needs to go and who needs the information. And then you start designing. Use flow charts, Gantt charts, pseudocode. You start looking at the design of how things would flow where. Big step is the development. You're going to go ahead and do it. So you're going to go ahead and build the house. Okay, you buy a lot, start doing that stuff. Dig a hole, so forth. For information systems, are you going to buy some software or are you going to create some software? This being more expensive, you could look at software like Web Advisor here at the college. They can make changes to that, so it's kind of like buying the basics software you need and then adjusting it to match your needs. Sometimes you can buy a package to do just what you want. Or some people get to this point and they say, you know, we can outsource this part. Just send our data off into the cloud, let them manage it, and we get back out what we want. All kinds of decisions can be made here at a variety of costs. This would be the most expensive. Create your own system. In the analysis stage, there's a point to where you decide how you're going to test the different items. The test is built in the design. When you're developing, you have to test so that before you implement, you have a pretty good idea if it's going to work. When we implement, we can phase it in, put it in different parts of our company. We can put in different packages. We can run a pilot. You know, there's different ways of implementing it. You can do a direct cutover, the way you're doing it now, and just switch over to the new way. Sometimes you have to do that. So, implement, and then we have to evaluate. The evaluation then runs us back into a loop. You find out as you implement some items don't work. Then you have to analyze that, so it goes right back to the investigation stage. Analyze, you find out what's wrong, analyze it, design a fix, develop the fix, and implement the fix. In the software world, a lot of times it's called a patch or an update. And then the system, eventually you keep patching and patching and patching. You know, it kind of goes like this, and then it runs through, and then you fix it, and it's like anything, all of a sudden there's something new out on the market or a better way to do it, and you might end up saying, we're going to scratch this one, we're going to start all over for our investigation, and look at creating a new information system. So you go through a life cycle. Now, over here, I mentioned this very briefly, bottom-up design would be a lot like, to give a simplistic example, how you do a PowerPoint. Most people would not analyze and draw out all the slides, design them all specifically, then type them into the PowerPoint software package. You do this bottom-up. You make a slide, you see if we like it, make another slide, switch them around maybe. So you start a prototype and then you build on it. So that'd be bottom-up design. Works good in a lot of examples, even for information systems. A big issue is if you make a major flaw in your design, you might have to destroy the whole thing and start over. Now that works okay in a lot of information systems. It wouldn't work if you were building an air traffic control system. You can't just all of a sudden be trying it and say, whoops, it doesn't work. We have all these planes in the air. So you can just quickly think of subway systems and so forth, things that have to be well designed and laid out, because you can't have any mistakes in it. You can't have any mistakes. Well, and that's it for today.